This topic is about solving trigonometric equations in degrees and finding all the solutions in a given range. I will highlight the importance of sketching trigonometric graphs in order to help you to find all the solutions and ensuring you don't miss any out or add any extra solutions. I will demonstrate this using multiple examples. Feel free to pause as I demonstrate these skills. We will round the up solutions to one decimal place for all these examples. Okay, so the first example says solve sine theta is equal to 0.7, where theta goes between minus 180 to 80. So if I want to find theta, the first thing I need to do is apply inverse sine to 0.7, which gives me a value of 44.4 degrees in my calculator to one decimal place. Now, because we're looking at the sine graph, okay, I need to draw from minus 180 to 180. So imagine this is minus 180, this is minus 90, 90, and 180. The sine graph has a max of 1 and a minimum of minus 1. Then it starts off 0, goes to 1 at 90, goes back to 180. Similarly on this side, like so. Oops, rough sketch is enough. Doesn't have to be perfect. So sine of 44.4. So 44.4 is somewhere here. So this is where it hits it. So this is the value of 44.4. So this arrow is 44.4 degrees. So if I draw a line, horizontal line, going through 44.4, that means my other solution is here. And I also know this arrow also represents 44.4 degrees. So if I want to find this point, that is 180, take away 44.4 degrees. If I put that into my calculator, I get 135.6 degrees. So these are my two solutions. My only two solutions, because these are the only 2 points where my horizontal line hits the sine curve. So that is it. So these are the only two solutions between minus 180 and 180. Next example. Solve 2 cos theta is equal to 1.6, where theta is between 0 and 360. So the first thing is we've got a 2 in front of the cos. That means I can divide by 2. So cos theta is equal to 1.6 divided by 2, which means cos theta is equal to 0.8. If I do inverse cos to 0.8, I get my first solution. I get 36.9 degrees on my calculator. So I need to find all the solutions between 0 and 360. So I need to sketch the cosine graph between 0 and 360. Maximum of 1 and minus 1. Rough sketch again. Okay, 36.8 is somewhere here. So we're looking, this is 36, somewhere here roughly is 36.9. And this point, because of the symmetries of a graph, I know this is also 36.9 degrees. So I know to find this point, I need to do 360 take away 36.9. So if I do that in my calculator, I get 323.1 degrees. And those are the only two solutions within the range of 0 to 360. Okay, next example. Okay, this example is more complicated because we have, instead of having just cos theta and sine theta like the first two examples, we have something else in the input. We don't have just sine of theta, we have sine of theta minus 45. So we have a function within a function, and sine is being applied to theta minus 45, which makes it more complicated. So we need to do a substitution to make our life easier. So let u be equal to the thing inside the bracket what sine is being applied to. So theta minus 45 degrees. Okay, then we have, instead of sine of theta minus 45, we've got sine of u is equal to root 3 over 2. Okay, now because we've changed the equation to u, we need to change the range now as well. Okay, so if theta goes from 0 to 360, we need to find out what u will go in between. So if I want to find out what u is in between, I need to take away 45. So if I take away 45 from every single part of this inequality, then I get minus 45. 0 minus 45 is minus 45. Theta minus 45 is just theta minus 45. And 360 take away 45 is 315. Okay, that means because theta minus 45 is just u is between 315 and negative 45. So that is my range of u now. Okay, and that is my equation that I'm trying to solve. I'm just trying to solve this now. Okay, let me just undo that because I just wanted to highlight it, but I don't want it highlighted in my solution. Okay, so if I want to find out u, I need to do inverse sine of root 3 over 2. And if I put that into my calculator, I get u is equal to 60 degrees. Okay, so that means that is within my range because my range is between u. The values of u go from minus 45 to 315. Now if I look at the sine graph, going from minus 45 to 315, so I only need to go from minus 90, 180, 270, 360, 90, 180, 270, and 360. It's the sine graph, so it starts off at 0, goes up to 1, goes back to 0, minus 1, 0, and minus 1 there. Okay, I found my first solution, which is 60. So 60 is somewhere here. So this is 60. If I draw a line, it only hits the sine curve once, which is there. So that is also 60. So my second solution is going to be 180 minus 60 degrees, which is just 120 degrees. So u is 60 and 120, but we weren't trying to find our solution for u. We're trying to find a solution for theta. So that means theta minus 45 is equal to 60 degrees and 120 degrees. So all I need to do to work out what theta is add 45 degrees. Okay, so if I add 45 degrees, I get 60 plus 45 is 105 degrees, and 120 plus 45 is 165 degrees. So these are my two solutions in the range. Okay, in my next example, sine 3 theta is equal to 0.5. Theta is between 0 and 180, including 180. So here my function is 3 theta. So my inner function is 3 theta. Sine is being applied to 3 theta. So I need to do a substitution. Let u be equal to 3 theta. Then sine of u is equal to 0.5. Okay. Now, because I've got u is the equation that I'm trying to solve now, I need to adjust my range. So this is my range at the moment. So 0 is less than theta, which is less than or equal to 180 degrees. If I want to make it 3 theta, I obviously need to times by 3. So I need to do 0 times 3, which is 0. 180 times 3, which is 540. So to get from here to here, we're timesing by 3. Because we have to times theta by 3 to get 3 theta. Which means u, I just made a mistake, remember this one is a strict function. So that means u is between 0 and 540, including 540. So that is my range. That is my equation. Sine u is equal to 0.5. That means u is equal to inverse sine of 0.5. And if you put that into your calculator, you get u is equal to 30 degrees as your value. Okay, now I need to sketch to find my other solutions. Let's sketch it. So 90, 180, 270, 360, 450, 540. So I need to only have to go up to there. Again, sine graph goes from 1 to minus 1. Let's just do a bit higher there. It's a rough sketch, but we don't want to make it too inaccurate. 1 to minus 1. So sine graph starts at 0, 1 goes down, so on, like this. Okay, sine 30 is somewhere here, so this is 30 degrees. Okay, if I do this, then I know if this is 30 degrees, then to get that point, that is also 30 degrees. So this point will be 180 take away 30 degrees. So the second value is 150 degrees. Okay, again, to get this point, I know, again, using the symmetries of the graph, this is 30 degrees. So remember that point is 360. So it's going to be 360 plus 30 degrees, which is equal to 390 degrees. And the last one in the range is that one. So remember, it's a rough sketch. This is 30 away from 540. So it's going to be 540 take away 30 degrees, which is equal to 510 degrees. Okay, so those are 4 solutions, which makes sense. So normally, remember, every 360, we get 2 solutions normally for most values. So we've got 4. 1, 2, 3, 4 between 0 and 540. Okay, so that means u, which is 3 theta, which means 3 theta is equal to 30 degrees, 150 degrees, 390 degrees, and 510 degrees. So if I divide by 3, I end up getting theta, which is equal to 10 degrees. 150 divided by 3 is 50 degrees. 390 divided by 3 is 130 degrees. And 510 divided by 3 is 170 degrees. All within the range of 0 to 180. So those 4 solutions are the solutions I get in that given range. Okay, next example. So we've got tan now. So again, let u be the inner function which tan is being applied to, which is 2 theta plus 25. Then we have tan of u is equal to root 3. So we need to adjust the range now. So we've got 0 degrees is less than equal to theta, which is less than equal to 360 degrees. So if we've got 2 theta plus 25, first thing we need to do is times by 2 to get 2 theta. So we want 2 theta in the middle, which means 0 times 2 gives me 0. 360 times 2 gives me 720. And then I need to get 2 theta plus 25. So I need to plus 25 next, which gives me 25 in the left-hand side. 2 theta plus 25 in the middle. 720 plus 25 is 745. And the middle is now u, so u is between 25 and 745. So that's my range. Okay, so if I need to find u, now and to solve this equation, I do inverse tan of root 3. And if I do inverse tan of root 3, it gives me a value of that's wrong. It gives me a value of 60 degrees in my calculator. So inverse tan of root 3 is 60. Okay, now the tan graph. So I'm drawing it from 25 to 745. So it's 90, 180, 270, 360, 450, 540, 630, 720. I even need to go up to 810. Okay, now the tan graph, remember, has asymptotes at 90, so every 180. So if I were to roughly draw it, it looks like so. And then it goes like this. Now I'm sketching it, but once I've sketched it, I'll show you why tan graph. It's not so important to sketch it because there's a pattern, obviously. So 60 is somewhere here. So this is 60, and this is your first point with solution that you've already got. So if I draw a line, you can see all these other solutions, so you might get all these ones, yeah? So to get all these other ones, you realize all you have to do is, because tan graph repeats every 180, all you need to do is add 180 to get the next one. Okay, so you don't really need to look at the symmetries of the curve, tan curve, to find the next solution. You just need to add 180. So 60 add 180 gives you 240 degrees. You add 180 again, you get 420 degrees, which is still within my range of 745. Add 180 gives me 600 degrees. If I add another 180, I get 780, which is too far, okay, because I need 745. So those are my 4 solutions. So that, remember, 2 theta plus 25 was u. So that means 2 theta plus 25 is either equal to 60 degrees, 240 degrees, 420 degrees, and 600 degrees. First thing I need to do is take away 25. So when I take away 25, if I take away 25 first, because I need to undo the process. So 2 theta plus 25, adding 25 was the last thing. So I undo the adding 25, which is subtract 25. 60 take away 25 gives me 35 degrees. 240 take away 25 gives me 215 degrees. 420 take away 25 is 395 degrees. And 600 take away 25 is 575 degrees. The next thing I need to do is divide by 2 to find theta. When I divide by 2, I get 35 divided by 2 is 75 degrees, 17.5 degrees. 215 divided by 2 is 107.5 degrees. 395 divided by 2 is 197.5 degrees. And the last one, which is 575 divided by 2, is 287.5 degrees. And those are my 4 solutions. Next example, 4 cos 2 theta plus 20 is equal to 1. First thing I notice is 4 is on the outside, so I can get rid of it by dividing by 4. So I end up getting cos of 2 theta plus 20 is equal to a quarter. So now I know I've got in a function of 2 theta plus 20. So let u be equal to 2 theta plus 20. Then cos of u is equal to a quarter. I need to adjust my range now. So minus 180 is less than equal to theta, which is less than equal to 180. The first thing I need to do is times by 2. When I times by 2, I get minus 360 is less than equal to 2 theta, which is less than equal to 360. The next thing I need to do is add 20, which gives me minus 340 is less than equal to 2 theta plus 20, which is less than equal to 380, which means my u goes from minus 340 to 380, including the endpoints. Okay, which means if I do cos u is equal to a quarter, u is equal to inverse cos of a quarter. Now if I do that, u must be equal to, in my calculator, I get a number that goes on for quite a while. So what I'm going to do is I'm going to round it to 2 decimal places. Because remember, I want my answer to 1 decimal place. That means because I'm going to subtract 20 and divide by 2 to get my answer, I need to, in my intermediate working out, I'd rather round to 2 decimal places. So that's my first solution, 75.52. Okay, so I need to draw the cosine graph between minus 340 and 380. So minus 340 to 380. So I need to make sure I need to go up to minus 360 here. And this one needs to go up to 450. Okay, between 1 and minus 1, this is the cosine graph. So like so. $75.52 is the first one, which is here, somewhere here. So this is the first one. To find all the other solutions after you draw the horizontal line. So this is, whoops, what happened here? This is 75.52. So if you want to find this point, you know this is also 75.52. So the first one, so for this one, you have to do 360 take away 75.52. If you do that in your calculator, you get 284.48 degrees. Okay, next point you want to find is this point. Now, because cosine is symmetrical along the y-axis, that must be negative 75.52, because you know this point is 75.52. So it must be a mirror reflection of that. So the other value is negative 75.52. And again, because you know this one is minus, so 284.48, that one must be negative 284.48 because it's a mirror reflection along the y-axis. So I get minus 284.48. And those are the only 4 that are within the range. Okay, that means u, which is 2 theta, theta plus 20, must be equal to 75.52, 284.48 degrees minus 75.52 degrees and minus 284.48 degrees. The first thing I need to do is subtract 20. So if I subtract 20, I get 55.52 degrees. I get 264.48 degrees minus 95.52 degrees. The negative 284.48 take away 20 gives me negative 304.48 degrees. Next, I need to divide by 2. When I divide by 2 and I round to 1 decimal place, I end up getting 27.8 degrees, 132.2 degrees, minus 47.8 degrees, and minus 152.2 degrees. Okay, so those are my 4 solutions for theta. Remember, you're always solving to find theta. Okay, so solve 2 sine 2 theta plus 30 is equal to 0.8 between minus 180 to 360. Again, I've got a 2 there, so I can divide by 2, which is on the outside. So that means sine 2 theta plus 30 degrees is equal to 0.8 divided by 2. Sine 2 theta plus 30 is equal to 0.4. Let u be the function that sine is being applied to, which is 2 theta plus 30. Then sine of u is equal to 0.4. Next thing I need to do is adjust my range to find my range of u. So theta is going from 360 to negative 180. First thing I need to do is multiply by 2. So when I multiply by 2, I get minus 360 on the left-hand side and 720 on the right-hand side. Then I need to add 30. So when I add 30 to both sides, I get minus 330 on the left-hand side and 750 on the right-hand side. Okay, so now sine u is equal to 0.4, so I need to just solve that now. So u is equal to inverse sine of 0.4. Now again, because I want my final answer to be to 1 decimal place, within my working out, I'm going to round to 2 decimal place. So inverse sine of 0.4 gives me 23.58 degrees, and that's my first value. Okay, now the sine graph needs to be drawn for quite a bit because it's got my range is from minus 330 to 750. So 1, 2, 3, 4, that's up to 360. This is up to 540, 720, and go a bit more further, 810. Okay, all the way up to 810. Okay, let's just label this is 360. And this is 720. And here I need to go up to at least minus 360 because my range is from minus 330 to 750. Okay, so this is the sine graph. So it goes from 1 to minus 1. So like so. It's a rough sketch. Don't worry too much about the details. Okay, again, the first value was 23.58. So imagine this is 23.58. That's the first value. We're trying to find all the other values. Okay, this one will be 180 take away 23.58. Okay, so 180 take away 23.58 is 156.42 degrees. Okay, next one is this one. So this one is, because this is 23.58, the arrow there. So this is going to be 360 plus 23.58, which is the same thing as 383.58 degrees. Okay, next one is this one. So this part is 23.58. So this is 540 take away. Whoops. Let's write it down. That is 540 take away 23.58. which gives you 516.42 degrees. Okay, the next one is here. Again, this is 23.58. 720 plus 23.58 is within 750. So that gives you a value of 743.58. Okay, next one I need to go for is this one. So I know this is 23.58. So this point will be negative 180, take away 23.58, which gives me a value of minus negative 203.58. Okay, and this one will be 360, negative 360 plus 23.58. If you do that mentally in your head, that is going to be less than negative 330. So that one is not a point that I want. It's not within the range. So I've got 6 values. Okay, so that means 2 theta plus 30 must be equal to 23.58 degrees, 156.42 degrees, 383.58 degrees, 516.42 degrees, 743.58 degree, and minus 203.58 degree. The first thing I need to do is subtract 30 to get 2 theta. So when I subtract 30, I get minus 6.42 as my first value. I get 126.42 as my second value. Subtracting 30, I get 353.58. 516.42 take away 30 gives me 486.42. 743.58 take away 30 is 713.58 degrees. The last one, negative 203.58 take away 30 is negative 233.58. The last step is I divide by 2 and I round to 1 decimal place. I get minus 3.2 degrees, get 63.2 degrees, 176.8 degrees, 243.2 degrees, 356.8 degrees, and negative 116.8 degrees. So I've got 6 solutions in that range. Okay, next question. This one's a bit more complicated. You've got sine squared 2 theta is equal to 1. Theta is between 0 and 360, including 0 and 360. Now think about notation, okay? So sine squared 2 theta means sine 2 theta squared. Now you don't normally assume it will be written like that. Most people think this will be written as sine 2 theta squared, but it's very unclear whether the 2 theta applies to the square or the sine, so we don't write it like that. So just remember, sine squared 2 theta is the same thing as sine of 2 theta all squared. We just write it notation-wise like this. That means I can square root it to get what sine 2 theta would be, okay? So first thing I've got is sine squared 2 theta is equal to 1, which means sine of 2 theta is equal to the square root of 1. Now remember, when we do square root, we do plus or minus 1. So we're going to get 2 sets of solution. So solution 1, case 1, if you want to go through the 2 sets of solution, is sine 2 theta is equal to positive 1. And case 2 will be that sine 2 theta is equal to minus 1. Now just solve each one separately. Okay, so because again we've got inner function 2 theta, so let u be equal to 2 theta, then sine of u is equal to 1. Okay, and if we do it for this one, let u be equal to 2 theta, then sine of u will be equal to negative 1 here. Again, because we know the range is for theta, we need to find the range for u. Okay, so 0 to 360 is for theta. So for 2 theta, because we have to double theta to get to 2 theta, to double 360, which is 720, and I need to double 0, which is 0, which means u goes from 0 to 720. Now, because the sine graph, I can draw the same one, solve both. Okay, so I need to draw from 0 to 720. So this is 360, and this is 720. And the sine graph goes like so. Okay, and 1 and -1 are the points of interest. It's very clear to see. Okay, so sine of u is equal to 1 for the first one. So I can use a calculator to find the first value. So inverse sine of 1. In your calculator, you do get 90 degrees. So u is equal to 90 degrees, the first one. To get your second one, you just need to add 360. So 90 add 360. So if this is 90 degrees, then because it repeats every 360, that must be 450 degrees. That's just two solutions. Those are the only two. For inverse sine, so for the second case, if you do inverse sine of -1, then you get in your calculator, you get a value, not in your calculator, or you can see it here, you're going to get this here, which is 270 degrees. I think if in your calculator you get -90, but that's not in your range, so you ignore that one. And to get the next one, if this is 270, you have to add 360. 270 add 360 is 630, so that must be 630 degrees. Okay, that means because u was 2 theta, 2 theta is equal to 90 and 450 degrees. Then theta must be half of those, which is 45 degrees and 225 degrees. In this case, again, 2 theta is equal to 270 degrees and 630 degrees, which means theta, when you divide by 2, you get 135 degrees. And divide by 2, 630 divided by 2 is 315 degrees. So your final answer is when you combine all these solutions, so you're getting 45 degrees, 225 degrees, 135 degrees, and 315 degrees. And one very last important example is when you got something like this. Solve tan theta is equal to tan theta times 2 plus 3 sine theta between 0 and 360, including 360. Now, the common thing most people want to do is they want to divide by tan theta, which means you're left with 1 on the left-hand side and 2 plus 3 sine theta on the right-hand side, and you're tempted to solve that. Now, that would be wrong because you're going to get rid of some solutions when you do that. Let me show you why with a very easy example. So imagine if I had something like this, x squared is equal to x, and then you decide to divide by x. So you get x is equal to 1, and you think that is your only solution. Okay, but remember when we got quadratics, we're not supposed to do that. We're supposed to make the right-hand side, one of the sides equal to 0. So if I subtract x, I get this. Okay, and then if I factorize it, then I get x times x minus 1 is equal to 0, which means either x is equal to 0 or x is equal to 1. So actually I have two solutions for this initial equation that I started off with, not one. So I've lost this solution. I've got rid of it. So we never divide by a factor. Oops. We never divide by it because we get rid of a solution. So what you need to do instead is factorize it and solve it. Okay, so let's try to delete this first. Okay, so let's go back to the original question. So what I'm trying to do is make one of the sides equal to 0. So let's move the tan theta on the left-hand side to the right-hand side. So I end up getting tan theta times 2 plus 3 sine theta minus tan theta is equal to 0. Okay. Now I can see there's a common factor of tan theta in both terms. So I can factorize that out. So inside the bracket, I end up getting 2 plus 3 sine theta from the first term. From the second term, I get a minus 1. So if you expand that, you'll see you get the first line is equal to 0. So I've got a product of two things that give me 0. So I either got tan theta is equal to 0, or I've got 2 plus 3 sine theta minus 1 is equal to 0. Now that simplifies to 3 sine theta plus 1 is equal to 0. I've got two different things that I need to solve, okay? Let's start off with the easier one, which is equal to tan theta is equal to 0, which means theta is equal to inverse tan of 0. If I put that into my calculator, the first solution I get is 0 degrees. Now looking at my range, I don't have a 0 is not included. So I need to cross that one out, yeah? So that's not a solution. So make sure you cross it out. If you don't cross it out, you're going to get 1 mark omitted in your final mark because you've added an extra solution which isn't there really. Okay, which isn't in the range. So the tan graph, remember, 90, 180, 270, 360 I need to go up to. We've got asymptotes at 90 and 270. So it looks like this, like so. So we've got the first solution, which was not in the range. So the other two solutions are this one and this one. So this is obviously 180, which is in the range. And the second one is 360 degrees, which is also in the range, okay? You can actually visually do this one in your head, so you don't have to actually sketch it. Okay, so the second case, we've got sine theta, 3 sine theta plus 1 is equal to 1, plus is equal to 0. So that means 3 sine theta is equal to minus 1, which means sine theta is equal to minus a third. So if I do inverse sine of a minus a third, I end up getting minus 19.5 degrees, which is obviously not in the range. So I cross that one out. I can use this to find my other solutions. So if I go from minus 90 to 360, okay, the sine graph is like so. Okay, minus 19 is somewhere here. So this is 19.5. Minus 19 is 0.5 is somewhere here. So we need to find these 2 points. So we know this is the same thing, 19.5, and that is 19.5. So to find this point, it's 180 plus 19.5, and to find this point is 360, take away 19.5. So that means the first value is 199.5 degrees, and 360 take away 19.5 is 340.5 degrees. So the final solutions for theta is the two solutions combined, 180 degrees, 360 degrees, 199.5 degrees, and 340.5 degrees.